The Earth is not standing still right now. Beneath your feet at this very moment, the ground is turning, carrying you eastward faster than the speed of sound, not by a little, but many times faster. You are spinning at over 1,670 kilometers per hour. And at the same time, the entire planet is racing around the sun at nearly 108,000 kilometers per hour. Every sunrise you have ever seen, every golden morning that crept over the hills and through your window was not the sun returning to you. It was you, the planet beneath you, quietly turning toward the light again. Tonight we will slow down time and follow that motion, from the tilt of Earth's axis to the hidden rhythm of its orbit, to see how every second of your life is written in movement. If this quiet journey brings you even a moment of peace, I am deeply grateful you are here. A gentle like or a soft tap on subscribe helps me keep creating these night voyages for curious minds and tired souls. Now let us begin with the first truth. Part 1. The sun does not move, the Earth spins. Every single second right beneath your feet, the ground is turning, carrying you eastward at speeds that would be impossible to survive if you could somehow feel them directly. But you cannot feel them, and that stillness, that complete and total absence of sensation, despite traveling at extraordinary velocity, is one of the most beautiful and mysterious facts in all of physics. Every wall, every city, every ocean, every mountain range, every sleeping child, every tree and stone and grain of sand on this planet, all of it is spinning through space at 1,670 kilometers per hour around the planet's invisible axis, while at the same time, the whole Earth is racing around the sun at nearly 108,000 kilometers per hour. This means that even as you sit perfectly still, reading these words, breathing slowly, letting your eyes grow heavy, you are moving tens of thousands of kilometers every single hour. And yet it feels like absolutely nothing at all. That illusion, the perfect stillness of motion, is one of the most extraordinary experiences any human being will ever have. And almost no one notices it because it has always been this way from the very first breath you took to this moment right now. You have never once been still, not for a second, not for a fraction of a second. You have never not been moving. You have never known true stillness even for a single heartbeat. The quiet reason why the sun seems to rise and set, though in truth it never moves, is this rotation. Each dawn is not the sun returning to us, but our own world gently turning toward the light. Each dusk is not the sun departing, but us rotating away into the shadow of our own planet. The sun simply holds its place, burning steadily, while we turn toward it and away over and over once every 24 hours, more or less. More or less because the true length of a day is not exactly 24 hours. Earth rotates once every 23 hours, 56 minutes, and 4 seconds, not quite 24 hours. Astronomers call this the sidereal day, measured by how long it takes for the planet to complete one full spin relative to the distant stars. The 24-hour day we live by is slightly longer because while the Earth spins, it also travels along its orbit around the sun. And it must rotate a little more each day for the same place on its surface to face the sun again. That tiny difference, just 4 minutes, reshapes the sky every night. In 1 month, those 4 minutes accumulate into 2 hours, and in a year, they accumulate into an entire extra day. So the stars that gleam above you tonight are not in the same positions they were last season. They have shifted not because the universe moved, but because you did. You and the planet beneath you, traveling slowly around the sun, changing your perspective on the vast ceiling of stars above. Our ancestors noticed this long before satellites or atomic clocks. They watched the changing length of shadows through seasons and years and recorded the drifting constellations with extraordinary patience and care. The ancient Egyptians built their temples with such geometric precision that sunlight would strike a single sacred point only once each year on the exact day of a solar event. A cosmic alignment encoded into stone, built by people who understood Earth's motion, not with mathematics or instruments, but with decades of careful watching and the quiet accumulation of knowledge passed from one generation to the next. In Newgrange, in Ireland, a passage tomb built 5,000 years ago, the inner chamber is plunged into darkness for almost the entire year. Except for one brief window at dawn on the winter solstice, when the rising sun aligns precisely with the entrance passage, and sends a shaft of golden light all the way to the back wall of the chamber, illuminating the carved spirals and diamonds for about 17 minutes, and then going dark again for another year. The people who built Newgrange understood the Earth's motion with extraordinary precision, 5,000 years before anyone had the word astronomy. Today, NASA confirms those same ancient rhythms using very long baseline interferometry, a technique that compares radio signals from distant quasars, objects billions of light-years away, to measure Earth's rotation to within a fraction of a millisecond. The precision is extraordinary. We can now measure how fast the Earth is turning more accurately than any ancient astronomer could have imagined. And yet, the fundamental truth they knew is the same truth we know: the Earth turns and the sky changes in response. But this rotation is not perfectly constant. It breathes, it fluctuates. Winds shift, oceans move, glaciers melt and redistribute their weight. Each change redistributes the planet's mass and slightly alters its spin, like a figure skater changing speed by pulling their arms in or spreading them wide after large earthquakes. NASA's Jet Propulsion Laboratory has observed measurable changes in the planet's rotation period, sometimes by just a few microseconds, but real and confirmed and documented in the scientific record. The Great Sumatra earthquake of 2004, one of the most powerful ever recorded, shifted enough mass inward toward Earth's axis to shorten the day by approximately 2.68 microseconds. The 2011 Tohoku earthquake in Japan, which triggered the devastating tsunami, shortened the day by another 1.8 microseconds. These are tiny numbers invisible to human senses, but they remind us that Earth's rotation is not a fixed, eternal constant. It is a living variable shaped by the planet's own geology, by the oceans, by the atmosphere, by the slow drift of ice, by every major geological event that redistributes mass on the surface or beneath it. But the rotation is also subtly shifting in another way that most people have never heard of. The Earth's axis itself wobbles, not the long 26,000-year precession we will discuss in a later chapter, but a shorter, more irregular wobble discovered by the American astronomer Seth Carlo Chandler in 1891. The Chandler wobble, as it is now called, is a small deviation in the orientation of Earth's rotational axis. It amounts to a change of about 9 meters in the position of the geographic pole, tracing a slow, irregular circle with a period of about 433 days, caused by the fact that the Earth is not a perfect, rigid sphere, but a slightly irregular body, whose fluid interior and elastic mantle respond to the stress of rotation in ways that pure mathematics alone cannot fully predict. This wobble combines with a simpler annual wobble driven by seasonal changes in the distribution of atmospheric and ocean mass. The two together cause Earth's poles to trace a spiral path that returns to its starting point roughly every 6.5 years. NASA's Jet Propulsion Laboratory monitors this polar motion continuously using very long baseline interferometry and satellite laser ranging, measuring the position of the pole to within a few centimeters, so that GPS systems, navigation satellites, and Earth observation instruments can be kept precisely calibrated against the planet's true rotational position. That precision, that stability of the rotation is what makes life possible. The rotation balances temperature across the globe, drives the jet streams that carry weather systems from ocean to continent, creates the Coriolis effect that shapes hurricanes and ocean currents, and produces the global day-night cycle that defines every ecosystem that has ever existed on this planet. Without it, our world would be unrecognizable, one side permanently scorched by unmoving sunlight, the other frozen in permanent darkness. No rain cycle, no seasons, no wind patterns complex enough to distribute heat around the globe, and almost certainly no life as we know it. Carl Sagan once said the Earth is a very small stage in a vast cosmic arena. He was right, but it is also a stage in motion endlessly spinning under invisible laws of angular momentum that link us to every rotating body in the universe, from electrons to galaxies. Spin is one of the most universal patterns in nature. Think about this: at this exact moment, your body, the air around you, even the atoms in your bones are all moving with exactly the same velocity vector, pointing in exactly the same direction at exactly the same speed. That is why you do not feel the motion. Everything that matters to you, everything you can touch and breathe and see, moves in perfect unison. It is a synchronization so complete, so elegant, that the human nervous system, which was built to detect differences in motion, registers nothing at all. The most elegant example of inertia ever experienced by any living creature on this world. If the Earth were to stop spinning suddenly, even for a single second, every object not anchored deeply into the crust would continue eastward at over 1,600 kilometers per hour. Oceans would surge across continents in massive waves, winds would tear across the surface, buildings would be swept away. The atmosphere itself would continue rotating long after the ground beneath it stopped. The results would be catastrophic beyond any human precedent. It is a theoretical scenario studied by geophysicists to understand how rotational energy shapes the stability of worlds. But the numbers alone are enough to inspire a kind of awe for the quiet miracle of the rotation we take for granted every day. Through the data of ESA's Gaia mission, scientists have observed that our planet's axis slowly wobbles through the long cycle of axial precession, completing a full cycle every 26,000 years. That gradual shift changes the orientation of Earth's poles and even which star we call the North Star. Thousands of years ago, it was not Polaris, but a star called Thuban in the constellation Draco. 12,000 years from now, it will be Vega, the bright blue star in Lyra, that appears almost directly overhead on summer nights in the northern hemisphere. So even our definition of north is temporary, everything we take as fixed, every direction, every season. The very idea of a day itself
32 seconds
is
into
the result of motion layered upon motion-nested rotations within orbits within larger journeys,
reducing the stress
all
on the shuttle
moving
as it
through
goes
a universe
transonic.
that does not hold still for anyone. And yet, inside that complexity there is something deeply soothing, because in all this movement Earth remains stable enough for us to live and breathe and sleep and dream. The same physics that propels us through space also shelters us in balance. The rotation that could destroy everything if it stopped is also the rotation that makes everything possible by continuing. So when you wake to the light tomorrow morning and see the glow growing on the horizon, remember, the sun did not rise, you did. The planet beneath you never stopped turning, carrying you gently and continuously back into the light. Part 2. Why does the sun speed up and slow down throughout the year? Have you ever noticed that the sun does not keep time, not perfectly? Some days it rises a few minutes earlier than it should, other times it lingers, setting later than expected. Even the most precise mechanical clock cannot perfectly track the sun, because the sun itself appears to change its pace across the sky, speeding ahead one month, falling behind the next, never quite keeping the same rhythm as the hours on your watch. But the truth is, it is not the sun that changes speed, it is the Earth. Our planet does not orbit the sun in a perfect circle, no planet does. It follows an ellipse, a slightly stretched oval path, first described with mathematical precision by the German astronomer Johannes Kepler in 1609. After years of painstaking observation and calculation using the meticulous data of Tycho Brahe, the Danish astronomer who had spent decades measuring planetary positions with extraordinary accuracy using instruments he built himself before the invention of the telescope. Kepler noticed that the planets did not move at constant speed, and that the shape of their paths was not circular, but stretched. And from those observations he extracted 3 laws that still govern every spacecraft trajectory we calculate today. According to Kepler's second law, known as the law of equal areas, a planet moves faster when it is closer to the Sun and slower when it is farther away. This is not arbitrary, it follows directly from the conservation of angular momentum. As the planet moves closer to the Sun, gravity pulls it with greater force, and it accelerates. As it moves away, that pull weakens and it slows. The same law that makes a spinning skater speed up when they pull their arms to their body governs the movement of every planet around every star in the universe. In January, Earth reaches perihelion, its closest point to the Sun, approximately 147 million kilometers away. In July, it reaches aphelion, its farthest point, approximately 152 million kilometers away. That difference of just 5 million kilometers across the breadth of the entire orbit changes everything about the rhythm of our sky. When Earth is near perihelion in January, its orbital speed reaches about 30.3 kilometers per second. 6 months later at aphelion, it slows to roughly 29.3 kilometers per second. That 1 kilometer per second variation may seem minor, 1 kilometer out of 30. But across millions of kilometers of orbital path, it reshapes the apparent motion of the Sun as we see it from Earth, making our days stretch and contract in subtle, measurable ways that have fascinated astronomers for centuries. Astronomers call this effect the equation of time one of the most quietly fascinating corrections in celestial mechanics. A mathematical expression of the gap between the Sun we actually see in the sky and the idealized mean Sun that our clocks are calibrated to follow. If you were to measure time by the Sun's true position, the exact moment it crosses the meridian directly overhead, and compare that to your watch, you would find a small, persistent discrepancy. Sometimes the Sun is ahead of the clock, sometimes it falls behind. Over the course of a year, that difference can reach up to about 16 minutes. This variation happens for 2 main reasons working together, like 2 instruments playing slightly out of tune. The first is Earth's elliptical orbit, which changes the planet's speed through the year. The second is the tilt of Earth's axis, which causes the Sun's apparent motion across the sky to vary with the seasons. Because the tilted Earth sweeps through its orbit at an angle, the Sun appears to move along the ecliptic, rather than directly along the celestial equator. And that angular difference changes the rate at which the Sun advances through the sky each day. Together, these 2 effects make the solar day the time between 2 consecutive noons slightly longer or shorter than 24 hours, depending on the time of year. In early January, when we move fastest around the Sun, each solar day lasts a little longer than average. Around early July, when Earth moves slowest, the solar day is slightly shorter. The difference can be about 30 seconds per day, which accumulates into noticeable shifts across the months. That is why sundials, those ancient yet remarkably accurate devices, do not always match your phone's clock. The Sun does not care about human definitions of time. It moves by physics, not by calendars. NASA's Solar Dynamics Observatory tracks these changes by recording the Sun's apparent motion against the fixed background of stars. When scientists plot that motion day by day throughout a full year, the Sun's path traces a graceful figure, 8 pattern in the sky, called the analemma. You can see it on some older world globes, a slender, elegant loop, shaped by both Earth's tilt and its varying speed in orbit. That figure 8 is a map of imperfection, a signature of how our planet's motion is slightly unbalanced, slightly off-center, and yet beautifully predictable, telling us that time itself is not a constant rhythm, but a reflection of motion. In December and January, when Earth races around the Sun at its fastest, the Sun seems to lag behind schedule, crossing the meridian a little later each day. In March and September, the Sun catches up. These oscillations explain why the earliest sunset of winter and the latest sunrise do not occur on the solstice itself, but weeks before and after it, a fact that surprises almost everyone who learns it for the first time. ESA's Gaia mission and NASA's JPL Horizon system now calculate these orbital variations with extraordinary precision. The data confirms that Earth's speed and distance from the Sun shift predictably every year, and that even slight gravitational tugs from the Moon, from Jupiter, from Venus, and from the other planets contribute tiny but measurable deviations to the orbit. According to PBS spacetime, the pull of Jupiter and Saturn causes Earth's elliptical orbit to stretch and squish slightly, on timescales of 5 to 12 years, and also causes the orientation of the orbital ellipse itself to rotate around the Sun over thousands of years. These are part of the same orbital forcing that eventually drives the ice ages through the Milankovitch cycles. In the 18th century, navigators at sea relied on this knowledge to determine longitude. They compared the observed position of the Sun with the expected mean solar time from their chronometer. A single minute of error could mean a position error of about 28 kilometers, and at sea that could mean the difference between arrival and shipwreck. That is why John Harrison's invention of the marine chronometer in 1761 changed navigation forever. It allowed sailors to cross oceans not by luck or rough estimate, but by precise alignment with the Sun's actual position, measured against a clock accurate enough to hold the difference across months at sea. Today, atomic clocks aboard GPS satellites depend on even finer corrections. They account not only for the equation of time, but also for the effects of general relativity, because time itself flows differently at different altitudes and velocities. Without these adjustments, GPS errors would accumulate by 10 kilometers per day. So when your phone tells you exactly where you are, it is really combining the work of Einstein, Kepler, centuries of celestial observation, and the quiet equations of orbital mechanics, all to synchronize your heartbeat with the motion of a spinning, orbiting planet. The equation of time is more than a mathematical curiosity. It is a reflection of our planet's imperfect perfection, proof that the natural world never truly repeats, and that even the most stable cycles contain hidden variations, beautiful and exact. Part 3, does true time really exist? Here is a strange and quietly unsettling fact. There is no single moment shared by everyone in the universe. Even this very second, as you read these words, does not happen at the same time everywhere. For someone moving very fast relative to you, this moment is shifted, stretched in a different position on the river of time. The faster you move, or the stronger the gravity you are in, the slower your clock runs compared to someone who is still or far from any massive object. This is not philosophy. It is physics tested and confirmed by experiments with real clocks on real airplanes and real satellites and real atomic transitions measured to extraordinary precision. For thousands of years, the passage of a day meant one rotation of Earth, one sunrise, one sunset. Time was the sky, and the sky was time. They were the same thing, inseparable. But as our instruments grew more precise, we discovered something unsettling. Nature's time and human time are not the same thing, and neither of them is absolutely true. In classical mechanics, time was absolute. It flowed everywhere at the same rate, independent of anything else. A river without banks, moving at a fixed pace for everyone and everything simultaneously. That idea worked perfectly for Isaac Newton, who described it as absolute true and mathematical time of itself, and from its own nature, flowing equably without relation to anything external. But in 1905, a young patent clerk named Albert Einstein shattered that certainty, not with an experiment, but with a thought. Einstein's special theory of relativity showed that time is not an independent background flowing the same for everyone. It is woven together with space into a single four-dimensional structure that physicists call space-time. According to his equations, time only has meaning when compared to motion. The faster an object moves, the slower its time passes relative to a stationary observer. Two people moving at different speeds will measure the same event at different times, both of them correct in their own frame of reference. This effect, called time dilation, is one of the most tested predictions in all of physics. In 1971, scientists Haferl and Keating flew atomic clocks aboard commercial airplanes traveling east and west around the Earth. When they compared those flying clocks to identical ones that had stayed on the ground, the airborne clocks were off by billionths of a second. Exactly as Einstein's equations predicted, not approximately, not roughly exactly. The implication is profound. Those clocks did not malfunction. They were not poorly calibrated. They measured something real. Time itself had passed at a different rate for the clocks in motion than for the clocks at rest. The universe kept different hours for different objects, depending on how fast they moved and how deep they sat in gravity. Today, the same correction is vital to the operation of the global positioning system. Each GPS satellite orbits at about 14,000 kilometers per hour, and their clocks tick slightly faster than those on Earth because they are farther from the planet's gravity. And also slightly slower because of their velocity. The net effect without correction would be a GPS drift of roughly 10 kilometers per day, which would make the system useless for navigation. Every time your phone finds your location, it is quietly applying Einstein's equations to correct for the fact that time runs differently up there than down here. Modern physics goes even further in general relativity. Einstein's later and even more remarkable theory time bends around massive objects. The stronger the gravity, the slower the passage of time. Near a neutron star, a second might stretch into minutes compared to time measured far away. Near a black hole, seconds can stretch into hours or longer depending on how close you approach the event horizon. NASA's Event Horizon Telescope confirmed this in 2019 by imaging the shadow of the black hole at the center of galaxy M87, a region where gravity distorts both light and time so severely that photons themselves spiral inward, trapped in a gravitational well so deep they cannot escape. Einstein described the relationship beautifully. Mass tells space how to curve, and space tells matter how to move. The result is that time flows differently in different parts of the universe, not as an illusion, not as a measurement error, but as a genuine physical reality. Two clocks placed at different heights on Earth, one at sea level and one on a mountain top, will accumulate different amounts of time over a year by a measurable and predictable amount. The mountain clock runs slightly faster because gravity is weaker there, and time flows a fraction more quickly. So what we call a second is only a local phenomenon, valid here on Earth under our planet's specific gravitational field and rotational speed. Elsewhere in the universe, a second is a different duration, larger near a black hole, smaller for something moving very fast. There is no master clock, no absolute second, no universal now that all observers share. When astronauts aboard the International Space Station return after 6 months, they are a tiny fraction younger than they would be if they had stayed on Earth. Not much, not enough to notice in daily life, but enough to measure, and the measurement matches the prediction every time. Time is not a backdrop against which events unfold. It is a participant in those events, shaped by mass, shaped by velocity, shaped by gravity, as much as any physical object. So does true time really exist? The answer physics gives us is that time exists, but not in the absolute way we assumed, not as a single shared river flowing at a fixed pace, but as a local measurement personal to each object, each observer, each frame of reference. The universe keeps its own time everywhere, and those times are only connected, not unified. And the Earth spinning beneath your feet curving through space around the sun, is embedded in that web of different times like everything else. A clock unto itself, keeping a time that is almost but not exactly universal. Part 4. Earth's place in a moving universe. We have talked about the Earth spinning and orbiting the Sun, but that is only the beginning of the motion. The Sun itself is not still, it is moving, carrying the entire solar system with it through the Milky Way galaxy. According to Space.com and Cornell University, the Sun and Earth are orbiting around the dense center of the galaxy at approximately 447,000 miles per hour, or 200 kilometers per second. The solar system orbits the center of the galaxy, taking roughly 230 million years to complete a single lap. The last time the solar system was in exactly this position in its galactic orbit, the Triassic period had just ended. The first dinosaurs were beginning to appear, and the continents were still joined in a single vast landmass called Pangaea. Since the Sun formed 4.6 billion years ago, it has completed around 20 revolutions of the galaxy. 20 cosmic years lived in the slow turning of the Milky Way. But even the galaxy itself is not standing still. The Milky Way is moving through the local group of galaxies, the loose cluster of several dozen galaxies to which it belongs. The Andromeda Galaxy, our nearest large galactic neighbor, and the Milky Way are rushing toward each other at about 70 miles per second, according to Space.com. In about 4 billion years, the two galaxies will collide, not in the violent, explosive way we might imagine, but in a slow, magnificent merger lasting hundreds of millions of years. As their vast structures interpenetrate and their stars redistribute into a single new galaxy. And beyond that, both the Milky Way and Andromeda are being drawn toward something larger. A concentration of mass so enormous that it tugs on galaxies millions of light years away. Astronomers call it the Great Attractor, and our entire local group, along with thousands of other galaxies, is flowing toward it. According to Futura, science is our local galaxy cluster is moving at about 2.1 million kilometers per hour toward the Virgo cluster. And this massive collection of galaxies is itself moving through the vast cosmic supercluster we call Laniakea. But where exactly is the Earth going? The solar system's motion through the Milky Way is far more complex than a simple circular orbit. According to PBS Spacetime, the Sun is going slightly faster than it should be for a perfectly circular orbit. It is drifting inward toward the galactic center at about 8 kilometers per second, and moving up and out of the galactic disk at about 7 kilometers per second. This slow drift upward means that in a few million years, the solar system will have climbed to around 300 light-years above the galactic midplane, before gravity slows the ascent and pulls it back down through the disk, plunging through to the other side before climbing again in an endless, slow oscillation. A path that traces not a circle, but a kind of flower pattern over millions of years. ESA's Gaia spacecraft, which maps the positions and motions of more than 1.5 billion stars, has shown that our Sun traces this slightly wavy orbit through the Milky Way, a spiral path that oscillates above and below the galactic plane about every 32 million years. As you go about your daily life, eating, breathing, sleeping, your body follows that same oscillation, carried gently through the thick arms of the galaxy by a star that does not know we are here. If someone could look down from far above from a position outside the galaxy entirely, they would see the solar system moving like a glowing ribbon, the planets orbiting the Sun drifting through the galaxy itself being drawn toward unseen structures in the universe. Every human, every cloud, every grain of sand, every word ever written, every thought ever thought is part of that motion. Neil deGrasse Tyson once said, "We are not just in the universe is in us." And that is literally true. The atoms in your body born in the hearts of ancient stars are now retracing their creators' paths through the galaxy. the iron in your blood forged in a supernova explosion, billions of years before the sun existed, is traveling now through the Milky Way inside you, inside this quiet room, inside this moment. And all of it, all the spinning and orbiting and flowing, feels like nothing at all, because you move with it perfectly continuously, without exception. Part 5. A day is not really 24 hours. Every clock on Earth is lying, but only a little. We have been told since childhood that a day lasts exactly 24 hours, yet in the language of astronomy that is not quite true. The Earth does not need 24 hours to spin once it needs 23 hours, 56 minutes and 4 seconds. A period, known as the sidereal day, measured against the background of the distant stars, the true fixed framework of the universe. A sidereal day measures one full rotation of the Earth, relative to the distant stars, the fixed background of the cosmos. It is the purest measure of Earth's true rotation used by astronomers to track the actual spin of the planet independent of where the sun happens to be. But while the Earth is spinning, it is also orbiting the sun. And during the time it takes to complete one full rotation, it has also moved about 2.5 million kilometers along its orbital path. By the time it completes 360 degrees relative to the stars, the sun is no longer in the same position in the sky. It has shifted slightly because the planet has moved around the curve of its orbit. To bring the same longitude back in line with the sun, Earth must rotate about 1 degree more, taking roughly 4 extra minutes. That is the 24-hour day, 23 hours, 56 minutes, plus 4 extra minutes to catch back up with the sun. That 4-minute drift accumulates rapidly. After 1 month, the stars appear to rise about 2 hours earlier than they did at the beginning of the month. After 1 year, the difference completes a full 24-hour cycle, which is why the constellations visible in the night sky change completely with the seasons. In July, the constellation Scorpio dominates the southern sky. 6 months later, in January, it is replaced by Orion. This seasonal rotation of the night sky is one of the most fundamental rhythms in observational astronomy. It was the first tool human beings had for measuring the passage of the year. Telescopes, especially those mounted on equatorial tracking systems, rely on sidereal time to follow celestial targets accurately. Unlike solar time, which drifts with the sun's position, sidereal time remains anchored to the fixed stars. When astronomers at the European Southern Observatory aim their instruments at a distant galaxy, they synchronize their systems not to the 24-hour clock of human life, but to the 23-hour 56-minute clock of the universe. This ensures the telescope moves precisely in sync with Earth's rotation, keeping the target centered in the field of view as the planet turns beneath it. Even space observatories like the Hubble Space Telescope and the James Webb Space Telescope operate using sidereal principles. Their pointing systems use reference stars catalogued with sub-arc-second precision to maintain perfect alignment. A deviation of even 1 second of sidereal time corresponds to about 15 arc-seconds of movement in the sky, enough to blur the sharpest images of the most distant galaxies. So while you measure your day by a clock, astronomers measure it by the stars. And the difference between those two measurements, 4 minutes every day, is the quiet signature of a planet that never stops orbiting. The Earth's spin rate is not perfectly constant either. Geological processes, ocean tides, the melting of glaciers, and even large storms slightly change the length of the day. According to NASA's Jet Propulsion Laboratory, the average day length increases by about 1.7 milliseconds per century, mostly due to tidal friction. The gravitational tug of the moon pulling at the oceans like a brake, slowing Earth's rotation fraction by fraction, century by century. That means hundreds of millions of years ago days were shorter, about 22 hours long during the age of the dinosaurs. Scientists confirmed this, not by calculation alone, but by studying coral growth rings and tidal sediment layers. Natural calendars written in stone and shell, showing that ancient Earth experienced about 400 days per year instead of the 365 we have now. Each day was shorter, but the total orbit time remained the same. The year was the same length, but it contained more rotations, more days, more sunrises and sunsets in the same orbital period. To keep our timekeeping in sync with Earth's slowing spin international time standards, occasionally add a leap second to coordinated universal time. Without these adjustments, the difference between solar and atomic time would grow into minutes over centuries, then hours over millennia. And eventually the clock and the sun would be so far out of alignment that noon by the clock would be midnight by the sky. The International Earth Rotation and Reference System Service monitors these variations using data from very long baseline, interferometry, and satellite laser ranging, tools that measure the planet's rotational position to within microseconds, allowing scientists to detect even the tiniest wobbles in Earth's spin. So the next time you see the clock strike midnight, remember it is midnight only on Earth's solar schedule. The universe has already moved on. Somewhere above you, the sidereal day has finished its turn precise, unbroken, and older than human time-keeping itself. A day is not really 24 hours. It is 23 hours, 56 minutes, and 4 seconds plus the motion of a planet that never stops moving around its star. Part 6. Tilted by 23.4 degrees, the small angle that controls everything. If the Earth were not tilted, if its axis stood straight up like a perfectly balanced top, there would be no summer, no winter, no seasons at all. The world would be locked in a permanent monotony. The equator always hot, the poles always frozen, and every sunrise exactly like the last for as long as the planet exists. But because our planet leans just 23.4 degrees from vertical, everything changes. This small tilt, called the axial tilt or obliquity, is the reason the Earth breathes in seasons. It decides when crops grow, when monsoons arrive, when polar ice expands and retreats, when migratory birds fly south, and when the light comes back after the long darkness of winter. In astronomy, 23.4 degrees may sound trivial, yet it is one of the most influential numbers in the history of life on this planet. The concept is simple, but its effects are profound. Earth's rotation axis is not perpendicular to the plane of its orbit around the Sun it leans. As the planet travels along its elliptical path, the northern and southern hemispheres take turns leaning toward the Sun. When the North Pole tilts, sunward sunlight strikes the northern hemisphere more directly. The same amount of solar energy concentrated onto a smaller surface area, producing higher temperatures summer. 6 months later, the tilt reverses, the southern hemisphere faces the sun, and the north cools into winter. NASA's Earth Observatory explains this clearly. Seasons are caused not by the Earth's distance from the sun, but by the tilt of its rotational axis. At perihelion, in January when Earth is closest to the sun, the northern hemisphere actually experiences winter because it is tilted away from the sun's rays. Distance matters less than angle. The geometry of sunlight does most of the work. This geometry shapes everything we know about climate. At the equator, sunlight arrives nearly perpendicular year-round, keeping conditions consistently warm. At higher latitudes, the sun's rays arrive at shallower angles, spreading the same energy across wider surfaces, producing cooler average temperatures. The tilt also explains why the Arctic Circle, at 66.5 degrees north latitude, experiences days without night in summer and nights without day in winter. For weeks the sun never sets or never rises depending on the season, a direct result of geometry of angle of tilt. The Earth's axial tilt is not fixed. It wobbles slowly, a phenomenon called axial precession, completing one cycle roughly every 26,000 years. This gradual change alters the timing of the seasons relative to Earth's orbit, subtly shifting long-term climate patterns over tens of thousands of years. The tilt itself oscillates between 22.1 degrees and 24.5 degrees. According to NASA, science, the Earth's axis is currently tilted at 23.4 degrees, or about halfway between its extremes, and this angle is very slowly decreasing. It was last at its maximum tilt about 10,000 years ago, and will reach its minimum tilt about 10,000 years from now. As the tilt decreases, seasons gradually become milder, resulting in increasingly warmer winters and cooler summers. This cooling of summers at high latitudes over time can allow snow and ice to build up into large ice sheets, and as ice cover increases, it reflects more of the sun's energy back into space, promoting even further cooling. A self-reinforcing feedback loop written into the geometry of Earth's orbit. These variations, together with the changing shape of Earth's orbit, are part of what scientists call the Milankovitch cycles. Named after Serbian astrophysicist Milutin Milankovic, who in the 1920s demonstrated mathematically how changes in Earth's orbit and tilt cause the periodic advance and retreat of ice ages. Milankovic worked by hand, performing decades of calculation to map how variations in 3 orbital parameters, the tilt, the eccentricity, and the precession, combined to alter the distribution of solar radiation at different latitudes across the year. The American Museum of Natural History describes his model as a climate time machine that can be run backward and forward to examine past and future climate conditions. The 3 Milankovitch cycles each operate on different timescales. The eccentricity cycle, the change in the shape of Earth's orbit from nearly circular to more elliptical, has a dominant period of about 100,000 years. The obliquity cycle, the change in the axial tilt, has a period of 41,000 years. The precession cycle, the slow wobble of the axis relative to the fixed stars, completes once every 25,000 to 26,000 years. These 3 cycles interact with each other in complex ways, producing the irregular rhythm of ice ages and warm interglacials. That has characterized Earth's climate for the past 2.5 million years. Scientists match these cycles to the actual geological record by studying deep-sea sediment cores and ice cores from Antarctica. The Vostok ice core drilled from the Antarctic ice sheet provides a direct record of temperature and atmospheric composition going back 800,000 years. That record shows remarkably regular variations that correlate with the Milankovitch cycles, confirming that orbital mechanics drives the planet's long-term climate rhythm. On its own, the current orbital configuration suggests that Earth should be in the middle of a stable interglacial period, and that the next ice age would begin many millennia in the future, approximately 10,000 years from now. Humanity's greenhouse gas emissions, however, have already altered the trajectory of that natural cycle significantly. Even more remarkable is how the tilt stays as steady as it does and why. The Moon plays a crucial role. Its gravitational pull acts as a stabilizing weight, preventing Earth's tilt from swinging wildly. Without the Moon, computer simulations show that the axial tilt could vary chaotically between 0 degrees and 85 degrees, producing catastrophic climate swings every few million years. As NASA scientists have noted, the Moon may be the reason Earth's climate has remained stable enough for life to develop. That quiet companion in our sky, so familiar, we rarely think about. It may be the reason any of us exist. Farmers have used these seasonal markers for 10,000 years to know when to plant and when to harvest, when to store food for winter, and when to prepare for the warmth to come. The tilt of the Earth encoded itself into the entire structure of human civilization, into agriculture and architecture, into religion and philosophy, into art and science, and into the quiet rhythms of daily life that we follow without knowing why. Because the planet beneath us decided to lean at just this angle, just this degree, billions of years ago. Part 7. the moon's role in Earth's stability, and the ocean's memory. The moon is so familiar that we rarely wonder what it is actually doing, beyond simply hanging in the sky being beautiful, reflecting the sun's light, waxing and waning through its monthly cycle. But the moon is one of the most physically active forces in the entire Earth system. It is not a passive ornament, it is an engine. The gravitational pull of the moon tugs at everything on Earth, but it tugs most powerfully at the oceans, which are fluid enough to respond. As the moon orbits the Earth, it pulls the ocean water on the side, facing it slightly toward it, creating a bulge. On the opposite side of the planet, another bulge forms simultaneously, because the Earth is being pulled toward the moon, while the water on the far side is left slightly behind. The result is two tidal bulges, one facing the moon, one facing away. And as the Earth rotates beneath them, any given coastline passes through these bulges, experiencing 2 high tides and 2 low tides every 24 hours. This tidal interaction does something remarkable over time. The ocean's friction against the seafloor as the tidal bulge tries to move around the planet acts as a brake on Earth's rotation. It slows the Earth down fraction by fraction, millisecond by century. As energy is transferred from Earth's spin to the moon's orbital energy, causing the moon to drift very slowly outward away from Earth at approximately 3.8 centimeters per year. This has been confirmed with extraordinary precision by laser reflectors left on the lunar surface by the Apollo astronauts. Scientists bounce laser pulses off these reflectors and measure the time it takes for the light to return. The measurements show definitively that the moon is retreating, that the day is lengthening, that the ancient tight gravitational partnership between the Earth and the moon is slowly relaxing, like a spinning couple releasing their grip and drifting gradually apart. When the moon first formed approximately 4.5 billion years ago from the debris of a massive collision between the early Earth and a Mars-sized body called Theia. It was much closer to the Earth, perhaps only 25,000 kilometers away, compared to the 384,000 kilometers of today. At that proximity, tides would have been enormous, hundreds of meters high, sweeping across the planet with tremendous force, and the Earth's rotation was far faster, a day lasting only 5 or 6 hours. The sky must have been extraordinary, a giant moon filling a huge fraction of the visible sky, rising and setting rapidly in a world of powerful tides and fast days. Over 4.5 billion years, both the moon drifted outward, and the Earth's rotation slowed to the 24-hour day. We know today, and the process continues infinitely slowly, but without stopping. In the far future, billions of years from now, if the Earth and moon survive long enough, the day will lengthen to match the month Earth, and moon will be tidally locked, each showing the same face to the other permanently, as the moon already shows the same face to us. Tides will become nearly still, and the slow transfer of angular momentum that has been operating since the beginning will have run its quiet course. The moon also stabilizes the axis, preventing the chaotic wobbles that would otherwise occur under the gravitational influence of the other planets. The moon is both brake and anchor, slowing the spin while keeping the tilt steady. Two opposing forces, each essential, each working on a timescale that makes all of recorded human history feel like a single breath. The tides also matter for life. The intertidal zone, that strip of coastline revealed at low tide and submerged at high, has long been considered a critical environment for the evolution of early life on land. Organisms that evolved to survive both underwater and in air, alternating with each tidal cycle, developed the physiological tools for the transition from sea to land. That eventually led, over hundreds of millions of years, to every land animal that has ever existed, including us. The moon's pull on the tides may therefore be one of the reasons we are here at all. Part 8. The magnetic field. Earth's invisible shield. There is an invisible structure surrounding this planet, one you cannot see, cannot feel, and have probably never thought about today. And yet, without it, this planet would be a barren rock scoured clean by radiation its atmosphere long since stripped away, and you would not exist. It is the geomagnetic field, Earth's magnetic field, generated deep inside the planet in the churning liquid iron of the outer core, extending far out into space, forming an invisible bubble around the Earth, called the magnetosphere. The magnetic field is generated by a process called the geodynamo. As NASA's Goddard Space Flight Center explains, nearly all of Earth's geomagnetic field originates in the fluid outer core. The outer core of the Earth, extending from about 2,900 kilometers to 5,100 kilometers below the surface, is composed of liquid iron and nickel at temperatures exceeding 4,000 degrees Celsius. This liquid metal is not still, it flows, driven by the heat escaping from the solid inner core below and by the rotation of the planet above. As NASA describes it, like boiling water on a stove, convective forces constantly churn the molten metals, which also swirl in whirlpools driven by Earth's rotation. As this roiling mass of metal moves around it, generates electrical currents hundreds of miles wide and flowing at thousands of miles per hour. Those electric currents in turn produce a magnetic field that also interacts with the fluid motion to create a secondary magnetic field. Together, the two fields are stronger than the original and lie essentially along the axis of Earth's rotation. A self-sustaining loop powered by the heat of the Earth's interior and shaped by the rotation of the planet. The rotation is essential. Without it, the fluid motions in the outer core would not organize into the coherent large-scale flows needed to sustain the dynamo. The Coriolis effect, the same force that organizes hurricanes and ocean currents, acts on the flowing iron in the outer core, aligning the fluid motions, according to Wikipedia, into roles aligned along the north-south polar axis, creating the ordered flow patterns that generate a stable magnetic field. The magnetic field extends from the core outward through the mantle and crust out into space, where it forms the magnetosphere, a teardrop-shaped bubble that is compressed on the sunward side by the pressure of the solar wind and stretched out on the opposite side into a long tail pointing away from the sun. The solar wind, a constant stream of charged particles flowing out from the sun at hundreds of kilometers per second, would strip away Earth's atmosphere in the same way it has stripped Mars if the magnetosphere did not deflect it. The magnetosphere is Earth's shield, and it is the spinning of the planet that keeps the shield alive. The South Atlantic anomaly is a region over South America and the southern Atlantic Ocean where the magnetic field is unusually weak. As NASA explains, this allows the solar wind to penetrate closer to Earth's surface than normal. It is created by the combined influences of the geodynamo and the tilt of Earth's magnetic axis. Currently, this anomaly is expanding westward and continuing to weaken in intensity. It is of active interest to NASA scientists who monitor it, both for its effects on Earth's atmosphere and as an indicator of what is happening to Earth's magnetic fields deep inside the globe. The field also weakens and strengthens over geological time and occasionally undergoes a complete reversal, with magnetic north becoming magnetic south and vice versa. The geological record of past field reversals, preserved in the magnetization of ancient lava flows and seafloor sediments, shows that the field has reversed hundreds of times over Earth's history, with an average interval between reversals of a few 100,000 years. The last reversal occurred about 780,000 years ago. During a reversal, the field does not simply flip overnight. The process takes thousands to tens of thousands of years, during which the field weakens, becomes disorganized with multiple poles appearing at different latitudes, and is generally much weaker than it is today. The consequences for life and for modern technology of a significantly weakened magnetic field remain an active area of research. The magnetic field strength was first measured precisely by Carl Friedrich Gauss in 1832 and has been repeatedly measured since, showing a relative decay of about 10% over the last 150 years. Earth's magnetic field is currently tilted at an angle of about 11 degrees, with respect to Earth's rotational axis, as if there were an enormous bar magnet placed at that angle through the center of the Earth. The magnetic North Pole's position has gradually drifted north-northwest by more than 600 miles since it was first precisely located by British explorer Sir James Clark Ross in 1831. Its forward speed has been accelerating in recent decades, migrating toward Siberia at speeds of up to 55 kilometers per year. Fast enough that the World Magnetic Model had to be updated ahead of schedule in 2019 to keep GPS and compass systems accurate. The key point for our journey tonight is this. The magnetic field, that quiet, invisible shield that makes life on this planet possible, is directly connected to the planet's rotation. Without the rotation, there would be no geodynamo. Without the geodynamo, there would be no magnetic field. Without the magnetic field, there would be no atmosphere, and without the atmosphere, there would be no us. The spin of the Earth, so ordinary, so taken for granted, so completely invisible to the senses, is the ultimate source of our protection. The quiet engine that keeps the shield alive day after day, rotation after rotation for 4.5 billion years. Part 9. How fast you are actually moving through the universe. Let us count it layer by layer, so that the full scale of your motion becomes impossible to ignore. Right now, at this very moment, the surface of the Earth beneath you is moving eastward at about 1,670 kilometers per hour, depending on your latitude. Faster near the equator, which covers 40,000 kilometers in 24 hours, at 1,600 kilometers per hour. Slower toward the poles, where the rotational speed drops to almost nothing at the geographic poles themselves. But always moving, always eastward, always spinning. The Earth is orbiting the Sun at approximately 108,000 kilometers per hour, or about 30 kilometers per second. According to Space.com, that is the equivalent of traveling from Rio de Janeiro to Cape Town or London to New York in about 3 minutes. Over the course of a year, the Earth travels about 940 million kilometers around the Sun. A journey completed once every 365 days, with the precision of a clock that has been running for 4.5 billion years. The solar system is orbiting the center of the Milky Way at approximately 720,000 to 900,000 kilometers per hour, depending on the measurement source, or about 200 to 250 kilometers per second. A single orbit of the galaxy takes about 230 million years. In those 230 million years, the solar system travels a distance that dwarfs any human concept of distance. And the entire Milky Way, all 400 billion stars, all their planets and moons and asteroids, all their dust and gas and dark matter, is moving toward the Great Attractor at roughly 600 kilometers per second, or about 2.16 million kilometers per hour. When you add all of these motions together, your total speed through the universe relative to the cosmic microwave background, the faint afterglow of the Big Bang, which represents as close to an absolute reference frame as physics can provide, is approximately 630 kilometers per second, or about 2.2 million kilometers per hour. In 1 hour, you travel 2 million kilometers. In one night's sleep of 8 hours, you travel roughly 16 million kilometers. While lying completely still without moving a muscle, without any sensation of motion whatsoever. NASA describes this beautifully. Our entire solar system is moving through the galaxy at roughly 220 kilometers per second, carrying everything within it along for the ride. So even when you sit quietly or lie down to rest, you are crossing millions of kilometers every hour. Through space, you will never visit past stars, you will never see through coordinates that will never repeat. The sensation of stillness, that complete and absolute feeling that you are not moving, is an illusion created by shared motion. From the perspective of physics, you are part of what is called an inertial frame of reference, a system where everything shares the same velocity unless that motion changes. Unless there is acceleration or resistance, The motion becomes invisible, it becomes indistinguishable from rest. It is the same principle that allows astronauts aboard the ISS to float weightlessly while traveling at 27,600 kilometers per hour. They are not escaping gravity, they are falling around Earth in perpetual free fall, in a curved path that precisely matches the planet's shape. The result is a serene, continuous glide motion without the feeling of movement. You are experiencing a gentler version of that same phenomenon every moment of your life. Your entire lifetime is a physical voyage traced through coordinates that will never repeat. The spot in space where you took your first step, your first breath, your first look at the night sky, is now billions of kilometers behind you, moving farther away every second. Every memory you carry, every moment that made you who you are, exists in a different place in the galaxy than where you are now. Carl Sagan once described this perfectly. We are passengers on a little blue dot drifting in the vast cosmic dark. That dot does not just float. It flies, its motion defines our nights and days, our years and seasons, even our sense of time itself. And the next time you close your eyes to rest, think about this. In the span of 8 hours of sleep, you will have traveled the distance from the Earth to the Moon and partway back again without taking a single step, without even knowing it happened. Part 10. The 11 days that disappeared from history. Imagine waking one morning to find that 11 days of your life had simply vanished. Not lost to illness, not forgotten in a blur of grief or exhaustion, but erased. Officially by decree of Parliament, gone from the calendar as if they had never existed. That is exactly what happened to the people of the British Empire in September of 1752, when they went to bed on September 2nd and woke up on September 14th. 11 entire days gone not through war, not through disaster, but through mathematics. This strange event, one of the most disorienting in the history of timekeeping, was not magic or myth. It was the consequence of humanity's long struggle to measure something deceptively simple, the length of one true orbit of the Earth around the Sun. The story begins centuries earlier with the Julian calendar introduced by Julius Caesar in 46 BCE. Advised by the Egyptian astronomer Sosigenes of Alexandria, Roman scholars calculated that a year, the time for one full orbit of Earth around the Sun, lasted 365.25 days. To account for that extra quarter day, they added a leap year every 4 years, adding one extra day to February. And the calendar, it seemed, was settled. But over centuries, a hidden drift accumulated like sand piling silently in an hourglass. The real tropical year, the time from one spring equinox to the next, is 365.24219 days, about 11 minutes shorter than the Julian value. 11 minutes per year invisible on any human time scale, but cumulative across centuries. After 128 years, the Julian calendar was one full day ahead of the seasons. After 500 years, it was nearly 4 days ahead. After 1,500 years, it was almost 10 days off. By the mid-1500s, the spring equinox, which should occur around March 21st, was actually happening on March 11th. The sun itself was out of sync with the human calendar. To astronomers and church officials of the time, this was not just inconvenient, it was catastrophic. The equinox determines the timing of Easter and of other religious festivals, of agricultural planting, dates of navigation charts. The skies no longer matched the dates written on parchment, and every year the discrepancy grew. So in 1582, Pope Gregory XIII, advised by the Jesuit mathematician Christopher Clavius, ordered a global recalibration of the calendar. The new Gregorian calendar would fix the drift by skipping 10 days immediately and by refining the leap year rule. Century years like 1500 or 1800 would no longer be leap years unless they were divisible by 400. This small change reduced the average year length from 365.25 days to 365.2425 days, far closer to the true tropical year. In Catholic Europe, Thursday, October 4th, 1582, was immediately followed by Friday, October 15th. 10 days erased the calendar, corrected the seasons, restored. But not everyone adopted the new system. Protestant nations suspicious of anything endorsed by the Catholic Church clung to the old Julian calendar for nearly 2 more centuries. Europe lived with 2 competing dates, one in Catholic countries, another in Protestant ones. The same day might be October 5th in one city and October 15th in another, across a border an hour's walk away. England and its colonies finally switched in 1752, by which time the Julian system was 11 days behind. Parliament decreed that September 2nd would be followed directly by September 14th, erasing the accumulated error in a single night. The result was one of the strangest transitions in history. An entire week and a half simply skipped. Legend says that angry mobs took to the streets shouting, "Give us back our 11 days." While historians believe the protests were exaggerated, confusion and mistrust were real. Contracts had to be rewritten. Birthdays shifted. Even the birthday of George Washington moved from February 11th, 1731, under the Julian calendar, to February 22nd, 1732, under the Gregorian. He gained a birthday in the transition, or rather history gave him a new one. Beneath the social confusion lay a profound truth that time as we record it is not absolute. It is a collaboration between cosmic motion and human precision, and that precision must constantly evolve to keep pace with the actual orbit of the Earth. NASA's Goddard Space Flight Center describes the Gregorian reform as a correction that restored harmony between human time and celestial time, realigning the calendar with Earth's actual orbit around the Sun. Today, the Gregorian system remains the international standard, its average year lasting 365.2425 days, just 26 seconds longer than the tropical year. That means it will take over 3,300 years for the Gregorian calendar to drift by a single day. An extraordinary achievement of astronomical observation and mathematical refinement. And yet, even this is not perfect. The Earth's rotation is slowing gradually due to tidal friction from the Moon. The length of a day increases by about 1.7 milliseconds per century, meaning that over thousands of years, even the best calendar will require further adjustment. That is why organizations like the International Earth Rotation and Reference Systems Service occasionally add leap seconds to coordinated universal time, microscopic corrections keeping atomic time synchronized with the planet's real rotation, the same principle that once demanded the 11-day correction of 1752, now expressed not in days, but in fractions of a second. Every date on every calendar, every clock on every phone, every schedule in every life exists because of this constant recalibration. From the 11 missing days to the leap seconds added by modern scientists, our timekeeping remains a moving target, forever chasing a planet that never stops turning. Carl Sagan once said we are like butterflies who flutter for a day and think it is forever. But the truth is, even during that brief flutter, the planet beneath us is adjusting, realigning, correcting its measure of motion against the stars. So when you look at your calendar, when you see February 29th, or think of those 11 days that once vanished in a night, know that this too is part of the same story. A world in motion measured by minds determined to keep pace with the heavens. Part 11. The atmosphere shaped by spin. The atmosphere that surrounds this planet, that thin layer of gas. Thinner relative to the Earth than the skin of an apple relative to the apple is not a static blanket, it moves, constantly in patterns shaped at the largest scales by the rotation of the planet beneath it. The most fundamental of these patterns is the Coriolis effect, the deflection of moving air and water caused by Earth's rotation. When air moves from high pressure to low pressure regions, it does not move in a straight line. The rotating Earth deflects it to the right in the northern hemisphere and to the left in the southern hemisphere. This deflection is not an illusion, it is a real physical effect, caused by the fact that different latitudes on the rotating Earth move at different speeds. The equator moves at 1,600 kilometers per hour, while the poles barely move at all. So a parcel of air moving from the tropics towards the poles carries its initial eastward momentum with it, and appears to deflect east relative to the slower-moving surface beneath. The Coriolis effect is why hurricanes and typhoons spin counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. It is why the prevailing winds in the mid-latitudes blow from west to east, creating the jet streams that aircraft ride to save fuel and time on eastbound flights. It is why ocean currents spiral in vast gyres, carrying warm water from the tropics toward the poles, and cold water from the poles back toward the equator, redistributing heat around the globe, moderating climate, making large parts of the Earth habitable that would otherwise be far more extreme. The atmosphere itself rotates with the Earth, but not perfectly. There is a constant interplay between the rotating surface and the atmosphere above it, with angular momentum being exchanged between them. Mountains slow the atmospheric flow, slightly large weather systems accelerate it. The angular momentum budget of the atmosphere is tracked by meteorologists and climate scientists because it affects the length of the day. A major warming of the Pacific Ocean associated with El Niño events, for instance, transfers enough angular momentum between the ocean and the atmosphere to change the length of the day by a few tenths of a millisecond, measurable with atomic clocks detectable in the data, confirming that the atmosphere is not separate from the Earth's rotation, but coupled to it. The atmosphere also protects the surface from space radiation working alongside the magnetosphere. The ozone layer in the stratosphere absorbs most of the ultraviolet radiation from the sun that would otherwise reach the surface and cause damage to DNA and living tissue. The denser lower atmosphere absorbs much of the remaining radiation and burns up the vast majority of meteors that enter from space. Those streaks of light we call shooting stars are rocky fragments, typically the size of a grain of sand, vaporizing in the atmosphere tens of kilometers above our heads before they can reach the ground. Without the atmosphere, the surface would be constantly bombarded by cosmic rays and solar radiation, and by the steady rain of small space debris that falls incessantly onto every unprotected surface in the solar system. And the atmosphere, like the magnetic field, like the tides, like the seasons, exists in the form it does because the Earth spins. The spin creates the Coriolis effect, which shapes the winds and the ocean currents, which distribute heat around the globe, which make the climate habitable, which allowed complex life to evolve, which produced us. Sitting here reading these words on a spinning world that has been spinning without interruption for 4.5 billion years. If this quiet voyage through time and space has brought you even a moment of peace, I am truly grateful you have shared it here with me. A gentle like or a soft tap on subscribe is not just support. It is encouragement to keep exploring these sleeping worlds of science together. And if you would like, I would love to know where you are and what time it is where you are listening. Your words, whether long or short, are like little stars that help guide the next journey. Until then, rest well, drift easily, and remember, even in stillness, we are always moving. Wish you a peaceful night, a deep sleep, and the gentlest dreams beneath the vast and turning universe. Part 11.5. Auroras, the northern and southern lights. There is a phenomenon that results from the intersection of Earth's magnetic field, its rotation, and the constant radiation from the sun that is so beautiful, so otherworldly, that for most of human history people believed it to be supernatural. The northern and southern lights, the aurora borealis and aurora australis, are shimmering curtains of light that dance across the polar skies in greens and pinks and violets, sometimes appearing as gentle, slow waves, sometimes as sudden explosions of color filling the entire sky. Something that reminds you, even if you have never seen one directly, that this planet is not a passive object, but an active system, constantly interacting with the space around it. The aurora is caused by charged particles from the sun, electrons and protons streaming outward in the solar wind at speeds of several hundred kilometers per second. Most of these particles are deflected by Earth's magnetosphere, the magnetic bubble created by the spinning dynamo in the core. But at the poles where the magnetic field lines converge and dip into the Earth, some particles are funneled down into the upper atmosphere, where they collide with oxygen and nitrogen molecules at altitudes of 100 to 300 kilometers. Those collisions excite the molecules, releasing the energy as photons of light. The characteristic green of oxygen at lower altitudes, the red of oxygen at higher altitudes, the blue and purple of nitrogen, all mixing in the sky in patterns that follow the structure of the magnetic field. The shape of the aurora is directly related to the structure of the magnetosphere, which is shaped by the geodynamo deep in the Earth, which is maintained by the rotation of the planet. So the auroras are ultimately a visual display of Earth's spin, the spinning iron of the outer core generating the magnetic field, the magnetic field protecting the atmosphere, and the atmosphere glowing where charged particles find their way through. During geomagnetic storms, when a coronal mass ejection from the sun slams into Earth's magnetosphere, the auroras expand toward the equator and become far more intense. The most powerful geomagnetic storm ever recorded, the Carrington event of 1859, produced auroras visible as far south as Cuba and Hawaii in the northern hemisphere. Telegraph systems worldwide failed, with some operators receiving electric shocks and some telegraph lines continuing to operate running on the current induced in the wires by the storm alone. NASA and ESA monitor the sun continuously with spacecraft like the Solar and Heliospheric Observatory and the Solar Dynamics Observatory, tracking solar flares and coronal mass ejections in real time to give early warning of major geomagnetic storms that could disrupt satellites, GPS power grids, and communications. The interaction between the sun and Earth's magnetic field is ongoing, constant, and consequential, and it is the rotation of the Earth that makes the shield, that makes the warning necessary. When you see an aurora, whether in photographs or if you are fortunate enough to see one in person, you are seeing the edge of the magnetosphere made visible. The boundary where the sun's energy meets Earth's protection, the place where the spinning core's magnetic field speaks to the stars. Part 11.6. The Age of the Earth and what it means for the spinning record. The age of the Earth is known with extraordinary precision, not from religious texts or philosophical speculation, but from radiometric dating, a technique grounded in the predictable decay of radioactive isotopes. When a rock forms as molten material solidifies, radioactive elements become locked into the crystal structure of minerals. And from that moment onward, those radioactive parent atoms decay into stable daughter products at a rate determined entirely by nuclear physics, unaffected by temperature, pressure, chemical environment, or any of the conditions that change on the surface of a living world. By measuring the ratio of parent-to-daughter isotopes in a rock and knowing the half-life of the decay, scientists can calculate precisely how much time has passed since the rock crystallized. The oldest rocks found on Earth's surface using uranium-lead dating have ages of about 4 billion years, but the Earth itself is older than its oldest surviving surface rocks. Because the early Earth was so geologically active that most of the original crust was recycled back into the mantle by plate tectonics and volcanic activity. To find the true age of the Earth, scientists date meteorites, which formed at the same time as the solar system and have remained largely unchanged since then. These ancient space rocks give ages of about 4.567 billion years, confirmed independently by multiple different radiometric systems: uranium, lead, potassium, argon, rubidium, strontium, all agreeing with each other to within fractions of a percent. The Earth is 4.567 billion years old, and we know this not with certainty born of assumption, but with precision born of measurement. 4.567 billion years of spinning. 4.567 billion years of turning through the day. 4.567 billion years of orbiting the Sun, each orbit accumulating the slow drift that lengthens the day by 1.7 milliseconds per century. Each century adding its tiny contribution to the long, quiet deceleration of the planet's spin. When you hold a piece of ancient rock, a granite cobble from a riverbed, or a fragment of sandstone from a cliff, you are holding hundreds of millions of years of Earth's rotation crystallized into mineral grains. The spinning written into stone, the motion of the planet encoded in atoms, waiting to be read by instruments sensitive enough to hear them. There is an intimacy in that thought that the age of everything around you is a direct record of how many times this planet has turned, and that the turning continues right now, with you on it. Part 11. Point 7. Retrograde motion and the revolution in understanding. Before Copernicus, before Kepler, before Galileo, the motion of the planets was a profound mystery. For most of human history, the accepted model of the cosmos placed the Earth at the center, with the Sun, Moon, and planets all revolving around it. This geocentric model was not simply ignorance, it was the best available explanation of what people actually observed when they looked at the sky. But there was a problem: the planets did not move smoothly across the sky. Most of the time, they drifted slowly eastward against the background stars, following the general direction of the Sun and Moon. But periodically they would slow down, stop, and then appear to move backward westward before stopping again and resuming their eastward drift. This apparent backward motion is called retrograde motion, and it was deeply puzzling to observers who believed the planets moved in perfect circles around the Earth. Ancient astronomers, particularly Ptolemy in the 2nd century CE, developed elaborate mathematical systems of circles within circles called epicycles to explain retrograde motion. A planet moved in a small circle called an epicycle, whose center itself moved in a larger circle called the deferent around the Earth. By carefully choosing the sizes and speeds of these circles, Ptolemy could calculate planetary positions with remarkable accuracy. The Ptolemaic system was not a failure, it was a sophisticated predictive mathematical model that worked well enough for navigation and calendar keeping for over 1,000 years. But Copernicus realized in the early 16th century that retrograde motion had a much simpler explanation. If the Earth was not at the center but was itself one of the planets orbiting the Sun, then retrograde motion was simply what happened. When the faster inner planets like Earth overtook and passed the slower outer planets like Mars or Jupiter. As Earth catches up with Mars and then overtakes it, the planet appears to slow and then reverse direction. Not because it is actually moving backward, but because our changing perspective from a moving Earth changes the apparent direction of Mars against the distant background stars. Galileo's observations through the telescope in 1610 provided the first direct observational evidence that not everything revolves around the Earth. The 4 large moons of Jupiter clearly orbited Jupiter, not the Earth. And the phases of Venus showed that Venus must orbit the Sun, going through a full cycle of phases from crescent to full, just as the Moon does. Something impossible in the Ptolemaic model, where Venus always sat between the Earth and the Sun and could never show a full phase. Kepler's laws followed, and then Newton's, and the picture became clear. The Earth is one of 8 planets, all orbiting the Sun, each moving faster the closer it is to the Sun. Retrograde motion is an illusion of perspective created by Earth's own motion around the Sun. and understanding that motion required humanity to abandon the assumption that we are the center of things, and accept that we are passengers on a moving world circling an ordinary star in one of hundreds of billions of galaxies. That acceptance changed everything. From the Copernican revolution grew Kepler's laws, which grew Newton's mechanics, which grew the understanding of gravity that allowed us to calculate the orbits of spacecraft, and send probes to the edges of the solar system, all because we were willing to accept the truth that the Earth moves, and that the apparent stillness we feel is an illusion created by the perfection of our shared motion. Part 11.5. How Earth compares to other worlds in their motion. We have spent this entire journey focused on Earth, and rightly so. It is the world we know intimately, the world whose rotation is encoded in our biology and our calendars and our clocks. But it is worth pausing to look at the other worlds of the solar system to understand how Earth's motion fits into the larger pattern and what makes our world unusual among the planets we know. Every planet in the solar system rotates and orbits, but each does so with its own character, its own history written in the angular momentum it inherited from the primordial solar nebula, and in the collisions, gravitational interactions, and tidal forces it has experienced since formation. Mercury, the innermost planet, orbits the Sun in just 88 days, but it rotates so slowly that a single Mercurian day lasts 59 Earth days. The combination of these two periods creates a remarkable situation. Mercury completes exactly 3 rotations for every 2 orbits around the Sun, a 3-to-2 spin-orbit resonance locked into place by the Sun's immense tidal gravity. Just as the Moon is locked to the Earth in a 1-to-1 resonance, always showing us the same face, Mercury was once thought to be tidally locked, but radar observations in the 1960s revealed the 3-to-2 resonance instead. A more subtle gravitational balance written into the orbital mechanics of the smallest planet, Earth. Reminder that tidal locking comes in more flavors than simple 1-to-1 synchrony. Venus is even stranger, rotating so slowly that its day is longer than its year. A single rotation of Venus takes 243 Earth days, while its orbit around the Sun takes only 225. So on Venus, a day is longer than a year, and it rotates in the opposite direction to most of the other planets. So on Venus, the Sun rises in the west and sets in the east. The reasons for this retrograde slow rotation are not fully understood. Venus may have been struck by a large impactor early in its history that reversed its spin or its dense atmosphere, creating tidal friction, with the Sun may have gradually reversed its rotation. Mars, in contrast, has a day almost identical to Earth's 24 hours and 37 minutes, a Martian day or sol, so similar to an Earth day that NASA mission controllers operating rovers on Mars follow a sol-based schedule, shifting their waking and sleeping hours by 37 minutes each day to stay in sync with the Martian day, demonstrating in miniature how completely our biology is tuned to the 24-hour day of this planet. Mars also has an axial tilt similar to Earth's, about 25 degrees, so it has seasons comparable to Earth's, but lasting nearly twice as long, because Mars's year is almost 2 Earth years. The Martian winters at the poles are severe enough that carbon dioxide itself, the main component of the thin atmosphere, freezes out of the air and deposits as dry ice on the polar caps, shrinking the atmosphere every Martian winter and releasing it again every spring. Jupiter rotates the fastest of all the planets, completing 1 rotation in just under 10 hours, despite being over 11 times the diameter of Earth, with cloud tops moving at over 45,000 kilometers per hour. This rapid rotation flattens Jupiter into a noticeably oblate shape and drives the extraordinary banding pattern of its clouds, shaped by the same Coriolis effect that organizes Earth's weather systems, but at planetary scale. The Great Red Spot, a storm raging for at least 350 years, is the most famous consequence of Jupiter's rapid rotation and Coriolis organized atmospheric dynamics, a single storm, larger than the Earth itself, preserved by the planet's spin for centuries. Uranus has perhaps the most unusual rotation of all. Its axial tilt is 97.8 degrees, so Uranus effectively rolls around the Sun. Each pole experiencing 42 years of continuous sunlight, followed by 42 years of continuous darkness, the most extreme seasonal cycle of any planet in our solar system. A powerful reminder that the 23.4-degree tilt we so carefully depend on is not the only possibility for an orbiting world. Each planet in the solar system has its own rotation, its own tilt, its own orbital period. Each one a different solution to the same equations of orbital mechanics and angular momentum conservation. And we orbit here on Earth, the third planet, with its 23.4-degree tilt, its 24-hour day, its 4 seasons, its magnetic field, its liquid oceans, and its living biology, all of it calibrated to the spinning of this particular world. You are on the luckiest world we know, and it is spinning. It has always been spinning, and it will keep spinning long after the last word you ever read has faded from memory. Part 11. Point 6. Retrograde motion and the revolution in understanding. Before Copernicus, before Kepler, before Galileo, the motion of the planets was a profound mystery for most of human history. The accepted model of the cosmos placed the Earth at the center with the Sun, Moon, and planets all revolving around it. This geocentric model was not simply ignorance, it was the best available explanation of what people actually observed when they looked at the sky over a lifetime of watching the stars. But there was a problem. The planets did not move smoothly across the sky most of the time. They drifted slowly eastward against the background stars. But periodically they would slow down, stop, and then appear to move backward westward before stopping again and resuming their eastward drift. This apparent backward motion is called retrograde motion, and it was deeply puzzling to observers who believed the planets moved in perfect circles around a stationary Earth. Ancient astronomers, particularly Ptolemy in the 2nd century CE, developed elaborate mathematical systems of circles within circles called epicycles to explain retrograde motion. A planet moved in a small circle called an epicycle, whose center itself moved in a larger circle around the Earth. By carefully choosing the sizes and speeds of these circles, Ptolemy could calculate planetary positions with remarkable accuracy. The Ptolemaic system worked well enough for navigation and calendar keeping for over 1,000 years, a tribute to the power of mathematical fitting even when the underlying model is wrong. Copernicus realized in the early 16th century that retrograde motion had a much simpler explanation if the Earth was not at the center, but was itself one of the planets orbiting the Sun. Then retrograde motion was simply what happened when the faster inner Earth overtook and passed the slower outer planets like Mars or Jupiter. As Earth catches up with Mars and then overtakes it, the planet appears to slow and reverse direction, not because it is actually moving backward, but because our changing perspective from a moving Earth changes the apparent direction of Mars against the distant background stars. Galileo's observations through the telescope in 1610 provided direct observational evidence that not everything revolves around the Earth. The 4 large moons of Jupiter clearly orbited Jupiter, not the Earth, and the phases of Venus showed that Venus must orbit the Sun, going through a full cycle of phases from crescent to full, just as the Moon does something impossible in the Ptolemaic model. Kepler's laws followed, and then Newton's, and the picture became clear. The Earth is one of 8 planets all orbiting the Sun, each moving faster the closer it is to the Sun. Retrograde motion is an illusion of perspective created by Earth's own motion around the Sun. Understanding that motion required humanity to abandon the assumption that we are the center of things and accept that we are passengers on a moving world, circling an ordinary star in one of hundreds of billions of galaxies. That acceptance changed everything from the Copernican revolution grew Kepler's laws, which grew Newton's mechanics, which grew the understanding of gravity. That allowed us to calculate the orbits of spacecraft and send probes to the edges of the solar system, and eventually to capture photographs of Earth itself from the outer solar system. The pale blue dot image taken by Voyager 1 in 1990 from a distance of 6 billion kilometers shows Earth as a point of light less than a pixel, wide, suspended in a beam of scattered sunlight. That image exists because we understood that the Earth moves, because we understood the laws of orbital mechanics well enough to send a spacecraft to that distance, turn it around, and photograph the world it came from. All because we were willing to accept the truth that the Earth moves and that the apparent stillness we feel is an illusion created by the perfection of our shared motion. Part 11.7. The spinning of time itself. There is one more thing worth saying about the spinning of this world, something that rarely gets said directly. The fact that the Earth turns is not just a physical fact, it is the foundation of everything we experience as time. The day is real because the Earth turns, the year is real because the Earth orbits, the seasons are real because the Earth leans. Without the spinning, there would be no yesterday and no tomorrow, only an eternal, undivided, now baked on one side, frozen on the other, no morning to wake up to, no evening to rest in, no spring to anticipate, no winter to survive. The turning of the Earth is the engine of time, as we experience it, not the abstract time of physics that bends near black holes, but the lived time of human experience, the time of sunrises and harvests, and returning seasons, the time by which we measure our lives and the lives of everyone we love. Every human culture that has ever existed has organized its deepest rituals around the rhythms of this rotation. The daily prayer timed to sunrise and sunset, the weekly rest, the seasonal festival, the annual return of the solstice. All of them acknowledgements in different languages and different traditions of the same fundamental fact. The Earth turns, and the turning of the Earth is the heartbeat of human life. The ancient Egyptians divided the day into 24 hours, not because 24 is a natural number, but because it divided neatly into 12 hours of daylight and 12 of darkness in the latitude of Egypt near the equinoxes. The Babylonians divided the circle into 360 degrees because they had a year of 360 days in their early calendar. The Mayans tracked multiple interlocking calendrical cycles, some based on the solar year, some on the lunar month, some on the synodic period of Venus. A complex interlocking clock, whose gears were all driven ultimately by the rotation and orbit of the Earth. Every measurement of time, every calendar, every clock, every schedule is ultimately traceable back to the spinning of this planet. When we say it is 3 in the afternoon, we mean the planet has rotated this many degrees since noon. When we say it is springtime, we mean the northern hemisphere is tilting toward the sun, which is a way of saying the Earth is in this part of its orbit around the star that gives us life. Time, as most humans experience it, is the story of the Earth's rotation, written in hours and days and seasons. The deepest gift of understanding Earth's motion is understanding why time feels the way it does, why mornings have the quality they have, why evenings feel different from midday, why seasons change something in us that runs deeper than the weather, why the return of longer days in late winter feels like a kind of salvation. These are not accidents of psychology. They are the biological response to the physical reality of a rotating, tilted, orbiting world. When someone says good night, they are acknowledging the turning of the Earth. They are saying the planet has rotated to the point where our part of it faces away from the sun, and it will rotate back again and bring us back to the light. When someone says, "See you tomorrow," they are making a promise that depends entirely on the continuation of a rotation that began 4.5 billion years ago and has never once missed a turn. The age of the Earth is 4.567 billion years, confirmed by radiometric dating of meteorites. 4.567 billion years of spinning, 4.567 billion sunrises, 4.567 billion trips around the sun. Each trip completing itself with the silent precision of a mechanism that needs no maintenance, only the conservation of angular momentum and the curvature of space around the sun. When you hold a piece of ancient rock, a granite cobble from a riverbed or a fragment of sandstone from a cliff, you are holding hundreds of millions of years of Earth's rotation crystallized into mineral grains. The spinning written into stone, the motion of the planet encoded in atoms waiting to be read by instruments sensitive enough to hear them. There is an intimacy in that thought that the age of everything around you is a direct record of how many times this planet has turned, and that the turning continues right now with you on it. Every civilization that has ever existed on this planet built its calendar on the assumption that the sun would return tomorrow, that the seasons would follow their ancient rhythm, that the stars would appear in their familiar positions. And in 4.5 billion years, the Earth never once failed to turn. That is perhaps the most reliable fact in all of human experience, more reliable than any promise, any institution, any human arrangement. So when you lie down tonight and the light begins to dim and the world grows quiet around you, somewhere on the other side of the planet, the sun is just rising and the light is growing on walls you will never see. People are waking to the same sun by a different name, going about their days in a language you may not speak on ground that looks nothing like the ground beneath you. And yet, we are all on the same spinning world, all riding the same orbit around the same sun, all moving through the same galaxy, all made of the same ancient stardust, all here for a brief moment in the long turning of things. It is enough to know that the world is turning to feel, even if you cannot feel it. That you are moving through a universe larger than any thought can hold, and more beautiful than any words can say. And that this small, unrepeatable life you are living is happening at the exact intersection of all that motion right now in this moment which will never come again. There is also something worth knowing about what comes after. After the moment you close this and let your mind go quiet. The Earth does not stop to wait for you. It simply continues. It has been doing this for 4.5 billion years. Through the emergence of the first cells in the ancient ocean, through the first organisms to breathe oxygen, which was at the time a deadly waste product, through the first animals with eyes, the first creatures to walk on land, through the age of the dinosaurs, which lasted 200 million years, 3 times longer than mammals have yet existed, through the asteroid impact that ended that era and the subsequent recovery, through the slow emergence of primates and eventually of the first hominids, through the entire span of human history which amounts to a single day in the life of the planet, through the construction of the first cities and the development of writing and the invention of mathematics, through every war and every peace treaty and every scientific discovery and every work of art, through the moment of your birth, through every day you have lived since then, through this moment, right now, the Earth has been turning, without pause, without preference, without awareness of us. And it will keep turning, through whatever comes after this moment, through the full span of whatever is left of human history, through the eventual death of the sun 5 billion years from now, when the star will expand into a red giant engulfing Mercury and Venus and possibly Earth itself, through the long, cold darkness that follows. The Earth, or what remains of it, still carrying the angular momentum it was given at its birth, still technically rotating even in the dark, even in the cold, because angular momentum once given cannot simply vanish. It can only be transferred. And in a sense, that is the most profound thing physics tells us about motion. It is not lost, it is passed on. The spin of the original cloud of gas and dust was passed to the planets. The spin of the planets is passed to their moons through tidal friction. The spin of dying stars is passed to the neutron stars they leave behind. The The spin of black holes is passed to the space around them through frame dragging. Nothing is lost, only transformed and transferred, passed forward like a secret through every generation of matter. From the Big Bang to right now, from the very first turning of everything that has ever turned, to the quiet turning of the world beneath you as you read these words. When you wake tomorrow morning and feel the light arriving at your window, that light has traveled 93 million miles through space to reach you. It was produced 8 minutes ago at the surface of a star, and it arrives now because the planet beneath you has turned to face the source. This is not a coincidence, it is physics. It is the same physics that has brought morning to every creature that has ever woken on this world. Every animal that ever opened its eyes to the light has done so because the Earth kept turning, because angular momentum is conserved, because the cloud that formed this solar system 4.5 billion years ago was spinning, and that spin was never lost, only passed forward. To you, to now, to this morning. Rest well. The Earth will keep turning even while you sleep. It will bring you back to the light. And perhaps the most intimate version of all these cosmic facts is this. The atoms in your body have already been through cycles of stellar birth and death. The carbon in your cells was forged in the nuclear furnace of a star that died before the sun was born. The calcium in your bones was assembled in stellar interiors billions of years before any life existed on Earth. The iron in your blood was scattered across space by a supernova explosion, and gradually swept up into the cloud of gas and dust that would eventually become the sun and its planets. And you are not separate from this process, you are its most recent chapter, a temporary arrangement of atoms that have been part of stars and oceans and mountains and other living things before they were you, and will be part of other things long after. All of those atoms carrying angular momentum through every stage of their journey. Spinning in stellar interiors, spinning in molecular clouds, spinning in the planet, spinning in the cells of your body right now. The same spin, the same angular momentum passed forward. From the very first moment of everything, to here, to you, to now. That is not a small thing. That is perhaps the largest thing. It always does. Part 12. How Earth's motion lives inside your body. We have spent this journey looking outward at the scale of planets and galaxies and black holes and galactic superclusters. But Earth's motion is not only written in the sky, it is written inside you in the rhythms of your biology, in the cycles of your hormones, in the timing of your sleep, and your waking in the subtle calendar that your cells keep without your awareness or instruction. Almost every living organism on Earth, from the simplest single-celled bacterium living in a tidal pool, to the most complex mammal, has organized its biology around the planet's rotation. This is not a metaphor, it is biochemistry verified by decades of molecular biology. Inside nearly every cell in your body there is a molecular clock, a network of interacting proteins that cycle through activation and suppression. With a period of almost exactly 24 hours, governed not by the sun directly, but by the ancient memory of the sun's rhythm. Encoded in your DNA over billions of years of evolution on a rotating world. These molecular clocks are called the circadian system, from the Latin circa diem, meaning about a day. The key components in mammals are proteins called clock and BMAL1, which bind together and activate genes, including two called period and cryptochrome. As period and cryptochrome proteins build up, they eventually suppress clock and BMAL1, turning off their own production. As their levels fall, clock and BMAL1 become active again, restarting the cycle. This feedback loop runs with a period of approximately 24 hours in every cell of your body. Your liver cells, your skin cells, your immune cells, your neurons, all keeping their own version of this molecular clock. independently and yet synchronized to each other by chemical signals that flow through the body. NASA's research into circadian biology has shown that these rhythms are not learned habits. They are genetic, they are ancient. Even in complete darkness in a cave with no external time, cues a human being will maintain a roughly 24-hour cycle of sleep and wakefulness. Body temperature, cortisol, melatonin, and dozens of other physiological variables will continue to oscillate on a near-daily schedule, because the cells themselves carry the memory of the planet's spin. This internal period without external time cues is called the free-running period, and it is typically slightly longer than 24 hours in humans, which is why in the absence of light cues humans tend to go to sleep a little later each day. Drifting slowly around the clock until the next morning, light resets the system. The master clock that synchronizes all the peripheral clocks in your body sits in a small region of the hypothalamus called the suprachiasmatic nucleus. About 20,000 neurons arranged in a tiny paired structure behind your eyes at the crossing of the optic nerves. This master clock receives direct input from specialized photoreceptive cells in the retina, called intrinsically photosensitive retinal ganglion cells. Cells that respond specifically to the blue wavelengths of daylight, and use that signal to reset the molecular clock each morning to match the actual position of the sun. So your body is not just keeping an internal rhythm, it is continuously synchronizing that rhythm with the turning of the planet. Every morning, when light falls on your retina, a signal travels to your suprachiasmatic nucleus, and the planet's rotation is literally calibrating your biology. When you travel across multiple time zones on an airplane, your body does not immediately follow the clock on the wall. It follows the old position of the sun. The mismatch between your internal clock and the new local time is what we call jet lag, and it is fundamentally a disagreement between your biology and Earth's rotation at your new latitude. Your suprachiasmatic nucleus must be gradually retrained by the new light schedule, resetting each peripheral clock in your body one by one. A process that takes several days and during which your digestion, your immune function, your alertness, and your mood are all misaligned with the local day-night cycle. The seasons, too, leave their mark in your biology. Research has shown that human immune function, hormonal levels, mood, and even cognitive performance vary systematically with the seasons, following the annual cycle of Earth's tilt and its effect on day length and light quality. The pineal gland, which produces melatonin, the hormone of darkness, responds to the changing length of night across the year, producing more melatonin in the long winter nights and less in the brief summer ones. This seasonal signal influences everything from mood to reproductive timing to the likelihood of seasonal depression. The condition, known as seasonal affective disorder, which affects millions of people, is essentially a response to the shortening of days in autumn. A biological system calibrated to the angle of Earth's tilt, interpreting the reduction in light as a signal to reduce activity and conserve energy. Migratory birds use the changing day length as a precise calendar, detecting the lengthening days of late winter as a signal to prepare for migration. Activating hormonal cascades that expand their fat stores, strengthen their flight muscles, and trigger the navigation behaviors that will guide them thousands of kilometers north, all triggered by a change of minutes in the length of daylight. A signal created by the angle of Earth's tilt and its orbit around the sun, filtered through the retinas and pineal glands of birds that weigh less than a coin. Even the timing of flowering in plants is governed by day length, a process called photoperiodism. Some plants flower only when days grow longer than a critical threshold in spring and summer long day plants. Others flower only when days grow shorter in autumn short day plants. By responding to the annual cycle of Earth's tilt, plants synchronize their reproduction with the seasons that will most favor the survival of their seeds. a strategy that depends entirely on the consistency of Earth's orbit and the reliability of the angle of its axial tilt. You are made of the same time. Your heartbeat divides the day into moments, your sleep cycles divide the night into chapters. Your hormonal rhythms divide the year into seasons of metabolism and renewal. All of it synchronized to a planet that has been turning at the same careful pace for 4.5 billion years. You are not just riding this world through space, you are keeping time with it in every cell in, every breath in, every quiet moment before sleep. Part 13. The Coriolis Effect. How the spin shapes everything that flows. Gaspard Gustave de Coriolis was a French mathematician and engineer, who in 1835 published a mathematical description of the forces acting on objects moving within a rotating reference frame. His work was originally applied to the mechanics of water wheels and rotating machinery in the early Industrial Revolution. But his equations described something far larger: the behavior of every fluid on the surface of a rotating sphere. Every ocean, every atmosphere, every weather system on every rotating world in the universe. The effect works like this: imagine you are standing at the North Pole and you throw a ball directly toward the equator. While the ball is in flight, the Earth beneath it is rotating eastward. The ball carries no memory of that rotation. It travels in a straight line relative to the fixed stars. But to someone watching from the surface of the rotating Earth below, the ball appears to curve, deflecting to the right in the northern hemisphere because the ground beneath it has moved eastward while the ball was traveling. From the ball's perspective, it traveled straight. From the perspective of the rotating Earth, it curved. The same deflection applies to every moving fluid, air and water. Air moving from the tropical high-pressure belt toward the equatorial low is deflected to the right in the northern hemisphere. Creating the northeast trade, winds the reliable winds that carried sailing ships across the Atlantic for centuries. Air moving toward the polar lows is also deflected, creating the prevailing westerlies, and the jet streams that carry weather systems across continents at speeds of 200 kilometers per hour or more. And that modern aviation exploits to reduce flight times across the Atlantic by hours on eastbound routes. The Coriolis effect also controls the rotation of storms. As air spirals inward toward the center of a low-pressure system, it is deflected counterclockwise in the northern hemisphere, creating the characteristic counterclockwise spiral of a hurricane, a typhoon, a nor'easter. Clockwise in the southern hemisphere for the same reason applied in mirror. A typhoon in the Pacific and a cyclone in the Indian Ocean rotate in opposite directions, not because the storms are fundamentally different, but because the Earth is rotating beneath them. The direction of rotation is a direct signature of which hemisphere of a spinning planet you are observing. The same principle shapes ocean currents, the great subtropical gyres that dominate each ocean basin. The North Atlantic gyre, the South Pacific gyre, the Indian Ocean gyre all rotate as a direct consequence of the Coriolis deflection of wind-driven surface waters. These gyres carry enormous quantities of heat from the tropics toward the poles, moderating the climates of coastal regions. The Gulf Stream that warms the coasts of northwest Europe is part of the North Atlantic gyre, a river of warm water flowing northeastward across the Atlantic, driven by both wind and the density-driven thermohaline circulation. Without the Gulf Stream, the climate of Ireland, Britain, and Scandinavia would be far colder, more like Labrador, which sits at the same latitude but lacks the warming current. The livability of large parts of northern Europe is a direct consequence of Earth's rotation. The Coriolis effect also shapes the behavior of large rivers. Rivers in the northern hemisphere tend to erode their right banks more than their left, because flowing water is deflected slightly to the right by the Coriolis force. The Mississippi River shows this pattern, as do many of the great rivers of Asia and North America. The land itself is being carved by the rotation of the Earth. Every drop of rain that falls, every wind that moves across a continent, every ocean current that circles a basin, carries within it the signature of Earth's rotation. The Coriolis effect is the planet writing its spin into the motion of everything that flows. A signature so pervasive that we forget it is there, but so fundamental that without it the weather patterns and ocean circulations of this world would be completely unrecognizable. Part 14. The many wobbles of the Earth. We have talked about axial precession, the great 26,000-year wobble of Earth's axis. But the Earth wobbles in multiple ways at multiple timescales, each wobble a different layer of the planet's motion, each one measured by the extraordinary precision instruments of modern geodesy. The largest of the short-period wobbles is called nutation, a small nodding motion of Earth's axis superimposed on the long, slow precession. With a dominant period of 18.6 years and an amplitude of about 9.2 arcseconds. This nutation was discovered by the British astronomer James Bradley between 1727 and 1747, during observations originally intended to measure the annual aberration of starlight. He found a small residual wobble in stellar positions that could not be explained by aberration, and realized it traced the 18.6-year period of the precession of the Moon's orbital nodes. The tilt of the Moon's orbit around the Earth varies on this cycle, and as the Moon's gravitational pull on Earth's equatorial bulge changes with that tilt, it produces the 18.6-year nodding of Earth's axis. On top of the main nutation, there is a smaller one at 6 months and various even smaller components at other periods, all driven by the changing geometry of the Moon's and Sun's gravitational influence on Earth's oblate shape. NASA's reference system for spacecraft navigation called J2000 accounts for all of these effects, pinning the coordinate system to a specific snapshot of Earth's orientation at noon on January 1st in the year 2000. Because without that fixed reference, the shifting axis would cause all astronomical coordinates to drift, making navigation calculations increasingly inaccurate over time. Below the nutation in scale is the Chandler wobble discovered by the American astronomer Seth Carlo Chandler in 1891. This is a free nutation, a wobble that arises not from external gravitational forces, but from the fact that the Earth is not a perfect rigid sphere. It has a slightly irregular interior, a fluid outer core, an elastic mantle, and shifting ocean and atmospheric masses. When a rotating body is not a perfect sphere, its rotation axis and its axis of geometric figure do not perfectly coincide, and the body wobbles as it rotates, tracing a small circle. For a perfectly rigid oblate Earth, this Euler wobble, as it was first theoretically predicted by the mathematician Leonhard Euler, would have a period of about 306 days. But the real Earth wobbles with a period of about 433 days. The difference was explained by Simon Newcomb as being caused by the non-rigidity of the Earth. The elasticity of the mantle and the mobility of the oceans and atmosphere subtly lengthen the period. The Chandler wobble has an amplitude of about 9 meters in the position of the geographic pole, meaning the North Pole traces a rough circle about 9 meters in radius over a period of about 14 months. This combines with an annual wobble driven by seasonal changes in the distribution of mass in the atmosphere and oceans. The two wobbles together cause the poles to trace spiral paths that return to their starting point roughly every 6.5 years. Because the Earth is not a perfectly rigid body, the Chandler wobble should theoretically decay, losing energy and amplitude over about 68 years. But it has been observed continuously since Chandler's discovery more than a century ago, which means something must be continually re-exciting it. For a long time, the source of this excitation was mysterious. But research at JPL in 2001 showed that from 1985 to 1996, the dominant excitation mechanism was ocean bottom pressure. The changing weight of ocean water pressing on the sea floor as ocean circulation patterns shifted. The Chandler wobble is being sustained by the oceans, the deep memory of circulation patterns driving a subtle oscillation in the planet's rotational axis. Even more subtle is a secular drift of the pole, a slow, steady shift in the average position of the geographic North Pole, which has been moving at about 3.5 milliarcseconds per year in the direction of Greenland and Hudson Bay. This drift is caused partly by motions in Earth's core and mantle, and partly by the redistribution of water mass as the Greenland ice sheet loses mass, and as land that was once crushed under the vast weight of the Ice Age glaciers continues to slowly rise. A process called isostatic rebound that has been continuing for 12,000 years since the glaciers retreated. The melting of ice sheets in the 20th and 21st centuries has noticeably changed the direction of this polar drift. Before around the year 2000, the drift was heading roughly toward Hudson Bay. Since then, it has shifted toward the east, moving toward Greenland. Researchers at NASA have confirmed that this change in drift direction is caused by the redistribution of water mass, as the Greenland ice sheet loses mass and as glaciers around the world melt. The planet's rotation axis is literally moving in response to human-caused climate change. The consequences of warming the atmosphere are being written into the geometry of the Earth's rotation itself. All of these wobbles and drifts are monitored by the International Earth Rotation and Reference System Service, using a global network of observatories measuring with very long baseline interferometry, satellite laser ranging, and GPS. The position of the pole is known to within millimeters, and it is this extraordinary precision that allows GPS satellites to give you a location accurate to within a few meters. Navigation spacecraft to arrive at their targets after journeys of hundreds of millions of kilometers, and telescopes to hold their gaze on a single distant star for hours without losing it. The Earth wobbles in many ways at many timescales, each wobble a different voice in the same long conversation between the planet and the forces that act upon it. And we listen in instruments as sensitive as any ever built, measuring the position of the pole to millimeters, tracking the quiet oscillations of a world that is never quite still. Part 15. The Foucault pendulum, the most elegant proof of Earth's rotation. In 1851, a French physicist named Léon Foucault performed one of the most beautiful demonstrations in the history of science. He suspended a heavy iron ball on a wire 67 meters long from the dome of the Pantheon in Paris, and set it swinging, and then he waited. A pendulum swinging freely in space will maintain the orientation of its swing forever. In the absence of any external force, it will continue swinging in exactly the same plane, back and forth indefinitely. This is a direct consequence of Newton's first law of motion. An object in motion continues in the same direction unless acted upon by an external force. Nothing is pushing the pendulum to change the plane of its swing. And so, relative to the fixed stars, it swings forever in the same unchanging plane. Foucault's pendulum continued to swing in the same plane relative to the stars. But over the course of hours, the floor of the Pantheon beneath it appeared to rotate. The pendulum was knocking over small pegs arranged in a circle, as the plane of its swing seemed to precess slowly, completing a full apparent rotation in about 32 hours at the latitude of Paris. Crowds gathered and watched in silence and wonder, the pendulum swinging steadily while the world turned beneath it. But the pendulum was not rotating, the Earth was. The apparent rotation of the pendulum's swing was simply the rotation of the Earth beneath it made visible for the first time, in a way that anyone could see and understand without instruments, without mathematics, without any special knowledge of physics. Just a pendulum and a floor and patience. Foucault had proven Earth's rotation not with data from distant stars or complex calculations, but with something you could watch in an afternoon. The period of a Foucault pendulum depends on latitude. At the North or South Pole, the pendulum would complete one full apparent rotation every 24 hours, perfectly tracking 1 day of Earth's rotation. At the equator, the pendulum would not rotate at all, because at the equator you are moving purely eastward with the rotation, not experiencing any rotational component perpendicular to the swing that would cause precession. At intermediate latitudes, the period is 24 hours divided by the sign of the latitude. At Paris, at about 49 degrees north, the sign is about 0.75, giving a period of about 32 hours. At London, at 51 degrees north, the period is slightly shorter. At Sydney, at 34 degrees south, the period is longer, and the rotation appears to go the other way because it is in the southern hemisphere. Today, Foucault pendulums hang in science museums and universities around the world. In the Smithsonian in Washington, in the Griffith Observatory in Los Angeles, in science centers from Tokyo to Sydney to London to São Paulo, each one quietly demonstrating the same truth, that the ground beneath it is turning, that the world is spinning, not because any instrument says so, but because a pendulum swinging freely in space says so, by the simple act of appearing to precess. There is something almost meditative about watching a Foucault pendulum. The slow, quiet swing, the barely perceptible drift of the plane of its motion. The wooden peg falling softly every few minutes as the arc sweeps past it. Each fallen peg a small mark of Earth's turning, visible in a room in an afternoon, in the silence of a museum on a quiet day. Foucault's genius was not in the mathematics which others had already worked out. It was in making the invisible visible, in turning the abstract fact of Earth's rotation into something you could watch happen, in real time, in front of your eyes. Part 16. What Earth looks like from space. From space, the motion of the Earth is not hidden. It is visible, and it is spectacular. Astronauts aboard the International Space Station orbit Earth once every 90 minutes, experiencing 16 sunrises and 16 sunsets in a single 24-hour day. As the station races around the planet at 7.7 kilometers per second, they watch the Terminator line the boundary between day and night, sweeping across continents as the planet turns beneath them. The shadow moving visibly over land and sea, as if the Earth were turning under a fixed spotlight. Which is exactly what it is. The famous photograph taken by the Apollo 17 crew in December 1972, known as the Blue Marble, is perhaps the most reproduced photograph in human history. It shows the Earth as a whole, a complete sphere, hanging in the blackness of space. Brilliantly lit on one side, shadowed on the other, the Terminator curving across the African continent, white swirls of cloud over the southern hemisphere, the tan and green of Africa visible below them. A direct, frozen visual record of the planet's rotation at a single moment. A moment that changed how billions of human beings thought about where they lived and what they shared. The overview effect, as astronaut Frank White named it in his 1987 book, is the cognitive shift reported by almost every astronaut who has seen the whole Earth from space. A sudden visceral understanding of the fragility of the planet, the thinness of the atmosphere visible as a faint blue line along the horizon, the absence of the borders that divide nations on maps, and the profound sense that this small ball of rock and water and air, spinning quietly in an enormous silence, is the only home that has ever existed for any human being. Astronaut Ron Garan described it as a sobering contradiction between the beauty of what he saw and the sad state of affairs on the surface. Edgar Mitchell said he had an instant global consciousness, a sense that the planet is a system that must be viewed as a whole. From the ISS, the rotation of the Earth is measurable, not just visible. As the station completes its 90-minute orbit, it passes from daylight to darkness and back again, tracking the planet's turning in real time. the night side lit not by the sun but by the aurora borealis and the glow of cities. The patterns of human settlement visible from orbit following the coastlines of continents, clustering around rivers and harbors, spreading across plains. The lights of civilization marking where the spinning planet has been inhabited for centuries and millennia. Time-lapse photographs taken from the ISS show the rotation directly. Stars streaming past in arcs as the station orbits. Lightning storms flickering silently across dark continents like slow thoughts. The slow pulse of city lights as the Terminator crosses from west to east. All of it the visual record of a world that has never stopped moving. Not since the day it formed from a collapsing cloud of gas and dust and inherited the spin of that cloud's angular momentum. 4.5 billion years ago. Part 17. The quiet fact of motion. We have traveled a long way tonight from the surface spinning beneath your feet to the galaxy you are crossing in your sleep. From the equation of time written in the figure 8 of the sun's annual path to the 11 days that vanished from a calendar in the middle of the 18th century. From the magnetic field generated by the spinning iron of the outer core to the cellular clocks inside your body that are synchronized to the turning of the planet. From the Coriolis effect shaping every hurricane and ocean current to the Foucault pendulum proving rotation in the silence of a museum. And all of this extraordinary complexity, all of this nested motion comes back to a single, simple fact. The Earth is moving. It has always been moving. It will always be moving. And in every moment of your existence, you have been moving with it. You have never been still, not even for the fraction of a second it takes a neuron to fire. Not even in the deepest sleep. Not even in the quiet moment just before you open your eyes in the morning and see the light growing on the wall. That light that tells you the world has turned again overnight and brought you back into the day. There is something deeply peaceful about this. About knowing that you do not have to do anything to be part of the universe's motion. You are already part of it, you have always been part of it. The planet carries you. The solar system carries the planet, the galaxy carries the solar system, and the great flowing structure of the cosmos carries the galaxy. In a river of motion that has no fixed banks and no fixed destination. Only the continuing fact of movement and the strange, beautiful gift of being carried along. Isaac Newton saw in motion a law, Einstein saw in motion a geometry, Carl Sagan saw in motion a story. And tonight, in the quiet of wherever you are, you can see in motion something simpler and perhaps more profound. A reminder that existence itself is not a fixed thing. It is a journey, and you are always on your way. The next time you stand in a doorway and watch the light change, or lie in bed listening to the world settle into silence, or look up on a clear night and find yourself counting stars, remember what all that light has traveled through to reach you. Remember where you are in the galaxy. Remember how fast you are going. And let that knowledge settle gently into you, not as something alarming, but as something true. You are on a spinning world in a turning solar system, in a spiraling galaxy, in an expanding universe. And all of it is carrying you. And none of it requires anything of you, except to notice and to wonder. If this quiet voyage through time and space has brought you even a moment of peace, I am truly grateful you have shared it here with me. A gentle like or a soft tap on subscribe is not just support, it is encouragement to keep exploring these sleeping worlds of science together. And if you would like, I would love to know where you are and what time it is where you are listening. Your words, whether long or short, are like little stars that help guide the next journey. Until then, rest well, drift easily, and remember, even in stillness, we are always moving. Wish you a peaceful night, a deep sleep, and the gentlest dreams beneath the vast and turning universe.